All right, are we on? Hey, good morning, everybody. Thank you for joining us. I know it's bright and early on day 3 of Build, so I appreciate everybody rallying, coming bright and early. How is everyone this morning? It's hard to see all. You're kind of scattered. We got the biggest room here, I think, but I really appreciate everyone showing up. My name is Justin Hutchings. I am a Senior Director of Product at GitHub. I have been working on GitHub Advanced Security for the last 5-ish years, and I'm so excited to tell you about some of the things that we've been doing and how you can bake security into your workflow with GitHub Advanced Security and some of the cool things that we're doing with AI. I'm joined by Madison, and I'll let Madison introduce herself.
Hi, everybody. My name is Madison Oliver. I'm a senior manager of our security advisory database curation team here at GitHub, which means I manage the team of folks who are curating our vulnerability data that is the back end of Dependabot and a number of other wonderful security automated tooling.
Excellent. OK, so quick show of hands for folks in the room. Apologies, folks online. I can't see your hands, obviously. How many of you are already using GitHub Advanced Security? OK, a good selection. That's excellent. I love to see that. Obviously, we're really excited about what we've done here. And so, for the rest of you, you might be asking, what is GitHub Advanced Security? And that's a perfectly reasonable question. So when we think about this, we think about advanced security fundamentally in a few ways. It's about bringing security capabilities to developers in their repository, making sure you don't have to click to a different page, go through login, go through friction. We bring the alerts to you in your developer experience. We also bring those experiences directly into the developer workflow, surfacing it in the PR, surfacing it in the IDE, all of those sorts of places so that we meet developers on their own terms. And of course, with all of the advances that we have with AI, we're also building in automatic remediation, and I will show you a little bit of that in just a moment. So you might be wondering, what are sort of some of the key capabilities? And I think there are 3 pillars that are really important to talk about. The first one is code scanning. And this is fundamentally about finding vulnerabilities in the code that you wrote. So that's where you're going to find your classic SQL injection or buffer overrun kinds of issues. And code scanning is fundamentally, it's powered by an engine that we have called CodeQL, and more than 2,000 open source queries that we have that go and find bad behaviors in your code. The beautiful thing about code scanning, something that we did from day 1, is we actually built code scanning to be interoperable by default. And so it also integrates with dozens of commercial and open source scanners. And so if we don't support the language or the scenario that you want, there's a really good chance that there's somebody out there that does, that integrates natively into code scanning. So you get one experience, a single pane of glass, all integrating those things for your code base. The next capability that we have is secret scanning. And I think it's a little bit self-explanatory, but what we're looking for are authentication secrets, passwords, tokens. And this is fundamentally powered by a huge partnership program. So we actually partner with the folks that issue the tokens, and we come up with patterns that really precisely identify things. And there's some interesting things here. When we started this journey some 5 years ago, GitHub tokens were 40-character alphanumeric strings. And try as you might to create a low false positive experience around that, those tokens made it impossible. And so we actually went and partnered with these providers, including ourselves, to change the way we mint tokens, to make them more identifiable by default. And that's really changed the game, where we have, for features like push protection, which I'll show you in a moment, we actually have 95% true positive rates because of the way we've adapted how the tokens are getting issued upstream. And of course, one of the other things that's incredibly important here is our ability to go and do automatic revocation. And so in public repositories, once you've checked in a secret, it's burned, right? Everyone knows about it. People are really good at finding it. We hear stories all the time about people that made a mistake. They checked in a secret for a cloud service that they're using, and they wake up in the morning with a $10,000 bill that someone mined crypto on. And so, for many of the partner patterns, we actually do automatic revocation on public repositories because, that opportunity for fraud is so large that we think that's the best solution. Last, certainly not least, this is what I work on every day, is 𝗦𝗲𝗏𝗏𝗏. 𝗦𝗏𝗏𝗏 is our dependency scanning tool. It looks for vulnerabilities in the code that you're inheriting from open source. It's powered by our GitHub Advisory database, which is open source. It's licensed under the Creative Commons license. And it's powered by contributions from folks like you. We actually support maintainers as one of the largest CVE issuers on the planet. It's interesting, when we started this journey a few years ago, I remember talking to prominent open source maintainers and asking them questions like, have you ever sought a CVE? And most of them said, no, I haven't. Then you ask, do you know how you would find one of those? And they said, no, I have no idea. And I think we've really changed the calculus on that, where I think most open source maintainers know that they can actually go and get a CVE directly from us from an experience in their repo. Okay, so I've talked a lot, obviously, but I think it's probably more impactful to see it, right? Do you want to see a demo? Folks up for a live demo? Okay, I love it, I love it. So again, live demos, you know how this goes. We're going to do our best here. Hang on.
Yeah, it should be that one.
Well, geez. All right, we might need a little help from the tech folks. I'm not seemingly able to switch the source here. Thank you. Believe it or not, we tried this like 20 minutes ago and it was completely fine. Okay. There's the green light. That looks a lot better. Excellent. Okay, super. Thank you all for bearing with me. Like I say, live demos, this is how that works. So this is just a test repo. Uh-oh, we have lost things again.
And we're back.
Okay, things are a little bit touchy. I will try not to move things. Okay, so this is a demo repo that we've got. And there are a bunch of things that I've been working on here. And one of the things that I'll point out right up front is actually, when I made this demo repo, I didn't have any vulnerabilities in my dependencies. And if we come over to the security tab, you'll actually see that I do now. And this just kind of goes to how the world evolves, right? Open source dependencies, even if you do all of your homework, you pick the perfect dependency, you made sure you picked one that's maintained really well, the world changes over time. And so, between the time I made this demo and today, this actually became vulnerable. And there's a new vulnerability in Next.js. But what I love here is it's not that big a deal. 𝗦𝗏𝗏𝗏 actually met me with a pull request that fixes that. And something that's really interesting here is we're seeing that this is a version update from 13.x to 14.x. And when this first came out, actually, last week, the compatibility score was showing at like 60-some%, because we were seeing that change may have caused some breaking changes for a lot of repositories. It looks like it's gotten better over time as more repositories have come into this. But it's a really interesting characteristic that we're actually able to see across the scale of GitHub how those changes impact developers. Okay, so that's one thing that just sort of happens randomly. But let's talk about what I'm doing in my pull request, because that's fundamentally what we as developers do. We write code, we make changes, we try and build things. So I have a pull request here. I started with a basic Next.js template, and I wanted to make it look kind of GitHub-y. And so I did a ton of changes here. I actually asked Copilot to build me this summary, which is why it is so immaculate. I would never have written this much detail myself. I think most of you in the audience know how that feels. And so, pull requests I think of as the time that we seek feedback from our peers. This is the time that we're looking for code review, looking for feedback, and of course, security insights, it's the perfect time for. This is when I'm ready to go and get that feedback about what I could be doing differently or better. And true to form, GitHub Advanced Security found issues. So in this particular repository, I have some debugging that I put in here where I'm actually logging the entire environment variable to the console. And that's the sort of thing that we do over the course of development as developers, where something wasn't working, you're trying to figure out what's going on in your environment, and you leave in one of these debug statements. And this is telling me it's clear text logging of sensitive information. And a reasonable question I might ask is, what does that mean? I have no idea. And so, we've, of course, got information. We've got boilerplate documentation that tells us kind of what this means, why this is a problem, what bad looks like, what good looks like. And, for a while, that was sort of as good as it got. But I'm so excited to show you all what we've been doing with generative AI, because we can actually do so much more now. And so we've got that particular vulnerability, and you can see that GitHub Advanced Security is actually following up with a contextual suggestion about exactly why this is a problem. And so this text that you see in the middle here, which is maybe a little small, I'll make it slightly bigger for folks. This text that you see in the middle here is actually not boilerplate. It's not stuff that just comes out of a static library. This is something where we're asking the LLM, Copilot, we're asking it to summarize why this is a problem for your code. It's providing all the context and telling me exactly how this is vulnerable in your code. And of course, this is a trite example, right? Logging my environment variables, it's not that complicated. But in more complicated vulnerabilities where you've got data flows across multiple classes, across multiple files, it could be actually relatively complicated to understand how that vulnerability is actually true. And so Copilot is actually giving us all of this context to tell us how this works. And that would be great if that was all we did, but we didn't. We actually decided to go a step further. Because we know what bad looks like and we know what good looks like, we can actually ask Copilot to meet us where we are with automatic fixes for those vulnerabilities. And that really changes the game, because you go from this world of, developer, you've made a mistake, you have a problem, it's on you to fix it, to, hey, you have a Copilot that is with you, that is coaching you, that is helping you to fix things and providing a suggestion. And so in this particular case, there's no way to do dump the entire environment variable to the console in a way that's not vulnerable. And so it actually just suggested that I comment it out. And I think that's a good example of why copilots they're not the pilot, right? They're giving you suggestions. And so this is the sort of thing that I could look at and say, commenting it out is fine, but that wouldn't work in our development style. We don't want to leave commented out code. And so, we make it really easy to go into code spaces or, into my own development environment, check that out, make some changes, and incorporate that in a way that's going to work with my team's development style. But, we look at this and say, wow, that should really reduce that mean time to remediate. And we're starting to see that in the data where people are really enthusiastically engaging with this. This feature is in public beta right now. So if you're already using Advanced Security, definitely go and check it out. It's available on a subset of our languages, and we're working on testing and bringing that to more of the languages that CodeQL supports over the coming months. But there's other things that we could look for in the pull request, of course. And so we'll keep kind of coming down here, and you'll notice that we have another comment from one of our advanced security capabilities, which is called dependency review. And it's letting me know that with the changes that I made, I actually picked some really bad dependencies. I've picked ones that are vulnerable on day one. I've picked ones that have licenses that my team can't accept, and also ones that are maybe a little bit risky. And so let's jump in and see what it's telling us about there. All right, so dependency review runs as a GitHub action. This is super customizable. We wanted to make this something that organizations could tweak, because obviously, the licenses that are OK in my organization might not be OK in your organization. The severities that you want to catch, those things might vary. And so we have this set up as a GitHub action. It's actually all deployed by policy using GitHub's rule sets capability. And so it's automatically targeting this based on whether my repo is tagged as a production repo or not. And that's great. That gives me the ability to go and manage that at scale, have a single place where that policy is set, and then automatically apply it. So let's scroll down. There's a whole bunch of warnings there, but I like this summary view here. And so it's telling me in my package lock, so my JavaScript dependencies, it's saying I've got a whole bunch of vulnerabilities. So glob parent has a high severity vulnerability. libxml_js2 has 2 of those. And those kinds of vulnerabilities on day one are a really bad idea. At the very least, I should go back and look at changing the version I'm using. But maybe there's more I need to do here. I also mentioned that there are license issues. So in my organization, they don't want us to use GPL v3. That's one of those copyleft licenses that requires you to open source your code. And my organization said, nope, 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 don't do that. And so we're able to catch that. And in this case, style lint, I should go back and check for a different version or a different license version of this. And then the last thing I want to show is the OpenSSF scorecard. Are folks familiar with the scorecard project? Has anyone seen this before? OK, you're in for a treat with scorecards. So this is actually a project from the Open Source Security Foundation. It's a Linux Foundation project that we're deeply involved with, and I hope many of you will be as well. And this is a group that's creating security features for public good. It's fantastic. One of those projects is a thing that's called Scorecard. And Scorecard fundamentally looks for risky behaviors in open source. Now, we don't want to put any maintainers on blast. We don't want to say that something is bad or good. But there are best practices that we can observe at scale. And for an organization, you might want to know how that project is maintained, some of the different characteristics of it. And so, these scores are out of 10, so don't let that scare you. But, we flagged ones that are below 3.0. And so libxml_js comes up, and, no shame to the maintainer here at all. But we're seeing some things that, like, our enterprise security managers might be a little nervous about. Like, there's no code review being used in this project. The maintainer checks directly into the main branch. There's no commits in the last 90 days. Is that a problem? It might be, actually. Or there's no signed provenance. So we can't say that every single project will have the same level of sophistication. But we want to give developers that insight, particularly when they're choosing new dependencies, to say, hey, these ones look like they might be risky. This is a good time to consider whether this is the right project for your needs, or if you should go and look for one that has different characteristics. OK, so far I've showed you in my pull request, I've showed you how we prevented a vulnerability that I wrote. We've also prevented checking in a whole bunch of dependencies that have vulnerabilities, have incompatible licenses, or maybe are just risky. And you might be thinking, great, that's enough, right? That's all I should need. Of course, there's more. Secrets. Now, secrets we uniquely don't show. Oh, of course, this always happens, but that's OK. It's a live demo. So secrets, by the time we get to the pull request, we're too late. The secret's already available for other people to see. And so we decided we're not going to scan there for secrets. Obviously, we do. But that's not the place we prevent things. We actually prevent things in a capability that we call push protection. Because we want to meet people in their IDE. We want to block things on the Git layer so that you don't have to roll the key, so that you don't have to rewrite your Git history, so that you have a much easier time. So this is a real PAT. Please don't use it. I'm going to blow it up right after this. And I have a .env file. This is the sort of thing developers use all the time to manage dependencies for secrets. And it ought to be in your gitignore file, so it's not a big deal, and you can inject that later into your environment. Ideally, you'd be using a key vault or something, but we're not in this case. And I'm just going to go ahead and commit this. So add env. That's great. And I'm going to push this, and we'll see how quickly this comes back. OK, great. That was really fast. And you can see that the Git protocol, so GitHub, has actually responded and said, we're blocking this push because pushes can't contain secrets. And in .env on line 1, at that commit, we have a secret that's actually been leaked. And that's exactly the information we need. It gives me information on how I can go rewrite my history here in my IDE and fix this before it's a real issue. Of course, there's definitely a break glass experience. We want to make sure that people can go and very quickly find and remediate these things. If you have an outage, you need to go and break glass, you can. But in general, we expect that folks will clean these up, and we see in the data that people are fixing these at a really high rate because finding this before it's a real problem is so important. Okay, so I've shown you all the prevention experiences we've got. I've shown you how we can do auto fixes. I'm going to show you one more thing, which is, this is all very developer focused. Any security folks in the room, folks that work for the security team? Okay, not in the room, but maybe online. And so one of the things that's important is, we don't think the security team wants to live in every repo. Oftentimes you have thousands or tens of thousands of repos in your organization. That's not going to work. It doesn't scale. And so we built the security overview because we wanted to make it really easy to create an experience for security teams to go and get that single pane of glass on what's going on. I've heard stories about a lot of teams where there's a repo and the entire team that was managing that repo got reorged onto another project, and then vulnerabilities showed up, and no one knew until the security team found out about it and said, ooh, hey, we forgot about that project. We got to go fix some problems. And so this kind of experience gives that security team those tools to make sure things don't slip through the cracks. And so this organization, this is our test repo. So it has way too many alerts. And honestly, I think it's not super useful to look at that because there's a lot of test code in here. And so what we've done is actually we're using GitHub's new custom repository properties, and we have one called isProduction, and we're just going to go ahead and filter this down to the ones that are in production. And you can see, wow, way better results. So not 142,000 alerts, 810, still not what we want to see, but this gives me a much better place to start from, and you can use that to go and prioritize where you go next. Other things that we're doing here, we're focusing on things like MTTR, the resolve rate, and how often those auto-fix suggestions are actually getting used. So you can report on the efficacy of your security program and talk with the engineers that you work with to make sure that you're doing the right thing across your security workflow to drive to that remediation. Okay, so that is the demo I wanted to show. I'm going to hand things off to Madison, who's actually going to speak a little bit more about how GitHub Advanced Security and some of the capabilities we have can be used to magnify your entire AppSec program. So Madison, please take it away.
Fantastic. So in addition to providing you with automatic fixes directly in your pull requests and directly in github.com, Copilot can also provide the same sort of information to you directly within your IDE. So here we have an example of Copilot helping me generate some, I'll say deliberately, vulnerable code. So this is supported in a number of different IDEs. You can see here that I'm using Visual Studio Code. I'm building what is a pretty standard JavaScript function that is querying for user data from a SQL database. Copilot is making some suggestions to me as I'm going through this. If I hit tab, I'm accepting the suggestion, and I am free to ignore it as I like. In addition to generating the code itself, Copilot can also help me generate documentation. I will openly say that's not always my favorite thing to do, so I'm more than happy to take some help in generating comments throughout my code. So it's explaining that this is a function that is extracting user data from a database based on the user-provided username. One of my favorite features of Copilot, especially built directly within my IDE, is the ability to have Copilot explain code to me. So I'm not always using or developing code that I myself have written, so I find this very helpful to get myself up to speed and up to pace with what it is that I'm looking at. So I'm having it describe the function that I was just talking about. It's including a lot of details. It's making some assumptions, noticing that execute query isn't necessarily defined in this file, but it's making an assumption about what it believes that that does based on names and the context that Copilot has that I've given it within my IDE. Most interestingly, at the very bottom of the explanation, we will see that it notes that this code is vulnerable to SQL injection because we are directly concatenating user input to the SQL query instead of using parameterized queries. So I, as a security person, think this is super interesting because I can go even a step further using Copilot. So I've written the code, identified that there is a vulnerability, and now on top of that, I can fix it directly within my IDE as well. So I select the function or lines of code that I want to make some changes to. Copilot suggests correctly here that we should actually parameterize our query to prevent SQL injection in this particular example, and I can very quickly just click accept, and my code is good to go. And this is all built directly within the IDE, directly within VS Code. It is so easy to use and one of my absolute favorite features. In addition to Copilot, some of the things that I'm particularly passionate about within GitHub Advanced Security is our partnerships with the community, both the open source community, security community, developer community. Wherever you sit, we are more than happy to partner with you in a lot of this. So we've talked about some of this with code scanning and secret scanning and Dependabot. Our advisory database, which is the vulnerability data that is the back end of Dependabot, is open to community contributions. So you, any GitHub user, are free to contribute information back to the database, correct something that might be incorrect or might actually be missing. And we have a team of security analysts that review this on an hourly, minute-by-minute basis. In addition to that, there is an opt-in feature for maintainers and developers on GitHub to turn on a feature called private vulnerability reporting. What that does is it allows another GitHub user, in theory a security researcher, somebody who has found a vulnerability in your project, to disclose that vulnerability directly to you privately without opening a public issue and zero-daying yourself and your other development team. And multi-repository variant analysis is built on CodeQL and allows you to run queries at scale. And I will give a quick demo of that in a couple of minutes. So our community contributions is particularly interesting because it allows the community to give direct, very open, very public feedback to the vulnerability data that is powering everything behind Dependabot, NPM audit, NuGet audit. You pick, all the data is free and open source, so it finds its way into a lot of other databases as well. So having the ability to take feedback from the community and to really rely on experts who are the SMEs in that project, that language, that field, really ensures that the data that we are then sharing with you through Dependabot and elsewhere is as accurate as it can be, as precise as it can be, and as relevant for you as it can be. Private vulnerability reporting allows the community to go directly to you. So if you don't want to set up a security alias, a security email address, a whole bug bounty program, we have a way within GitHub, again, built directly into where you are already developing your code for folks to submit that to you. And they can actually work with you to develop a fix in a private branch all before this is going public. So I will switch again briefly to show you what private vulnerability reporting looks like. So here is a security testing project I have set up. We can see here that I have security private vulnerability reporting enabled on this already. Nobody has yet submitted anything to me, but I can go and do that very quickly to show you. Show you what this could look like. So this is from the viewpoint of a reporter, somebody that is external to your organization or your project. They can come right here to your security page where you have this on, click report a vulnerability. They are then given this draft page, some draft template description work to start with. They would in here say, you know, there's a SQL injection in line 9. I won't make you sit here and watch me fill out this whole description, but I will do, let's see, vulnerable function. Let's say versions 2.3.0 before are vulnerable. I'm going to say, you know what, I think this is really, really high severity. You should really pay attention to this. And then I submit it. Well, it stops me because this was a template. And let's see, so I submit it directly to the project. This is all in draft state. None of this is yet public. If I go back over to my project, I can see that I have a vulnerability report waiting for me in the triage state. I can see all of the information that the user has given to me. I can see their name here, that they are the reporter. I can add additional collaborators, my security team, additional developers that I want to review this, and we can start a temporary private fork to start working on patches and remediation for this. I, as the maintainer, have the option to accept this and say, yes, this is a vulnerability, this is something that I want to work on, or reject this. In the interim, I can also have a private communication directly with the security researcher or the reporter on this to ask some clarifying questions, get some more information. And again, all of this is done privately, all pre-disclosure, and with the end goal of this being published and making its way into our advisory database. I will switch back over here very briefly. So multi-repository variant analysis is a really, really cool feature and a really cool tool. So while Copilot can maybe help you find vulnerabilities as you're developing them, and features like PVR can help you find vulnerabilities or learn about vulnerabilities once they're already in production, multi-variant, sorry, so many acronyms. Multi-repository variant analysis can help you go a step further and say, all right, I have found this type of vulnerability in my code. I own a number of other code bases across my enterprise. I think there's a really good chance that I've made the same mistake somewhere else in code. Let me go find that now that I know that this is likely a pattern that is surfacing within my code. So we can do this directly within VS Code. So I have a lot of this pre-run. So CodeQL backend takes a couple of minutes, and again, I'm not going to make you all sit through that. So I have a little of this already set up and already turned on. So I have a query in here. This is a CodeQL query that is specifically looking for a SQL injection, because that is the type of vulnerability that was reported to me, and that is what I want to look for at scale to find any more instances of this happening. So we talked a lot earlier about the community. Say, do I have this open somewhere? I think I do. So we talked a lot about the community as part of this and relying on the community and subject matter experts. This query is public. This is publicly available. This is a part of the CodeQL database. The community can contribute new queries to us. We also have internal security research teams that are actively looking for these and developing these queries themselves. So these are by no means stagnant and something that is being updated on a day-to-day basis, but is all public, all free, all open source. So I have in here my example query. I have the option to run this on the top 10 repositories that GitHub has defined, top 100, top 1,000. I also have an option within here to assign my own repositories that I would like to scan against to develop a list. So I have in here just the 2 that I'm using today for the demo, but if you're an organization that has hundreds, thousands, more than that, you can develop a list of exactly the ones that you would run something like this on. So I would run the variant analysis against all of these repositories. So I would run it against these 2 here, again, to save you some time. We can see that in my vulnerable node project, which is not where this vulnerability was reported, it has found the exact same type of SQL injection, not same verbatim, but exact same logic, exact same sources and sinks in this, and has alerted me that, you know what, this is a query that is working on user-provided value. You are not protecting ourselves properly on this. And I can go through and even look at the exact flow paths, where this is coming in, where it's being used throughout the entire state of my code to, again, determine, do I need to respond to this right now? How do I need to respond to this? And to what degree do I need to handle this? Which I think is particularly interesting. Now, from a security research perspective as well, you can also run these same sort of queries on a number of open source top 10 databases. So we have security research teams that are actively doing this and looking for vulnerabilities in open source projects and disclosing to those maintainers in the interest of raising the bar of security in the open source community and making everything better, right, one vulnerability at a time. So we can see that there are some other projects who do, unfortunately, very similar things. So there are different instances of the same vulnerability, and we're able to find this at scale. When I ran this last night, it took maybe 2-3 minutes. So that's really all the time that I'm saving you today by having this already pre-run. But it's truly so interesting and a really easy way to find these sort of issues at scale to really know that you are securing yourself holistically from a defense in depth perspective. And with that, that is all we have for you today. So we are happy to take some questions. Both my and Justin's contact information is above.
Yeah, so do we have any questions, I guess, first, online through our moderators? We can't see you over there. You're going to have to speak up. OK, no questions there. Any questions in the room? Otherwise, Madison and I will both be available in the hallways afterwards to chat with any of you for your questions you might want to take offline. We do have a question. Can we run a mic over? Apologies, we cannot see especially well into the audience, but I did see that one hand.
Hey, thanks. Yeah, we're off in the dark, aren't we?
Yeah.
Question, where does the code fixing feature sit at the intersection of Copilot and Advanced Security?
Yeah, absolutely. So it depends a little bit on which one you're talking about. So the one I demoed at the beginning, commercially is provided as part of GitHub Advanced Security. And so we don't require that to get auto fixes in your pull requests that you've also purchased Copilot for Business, Copilot Enterprise. We commercially included that in the GitHub Advanced Security capabilities.
Okay, but inside the IDE, that does require Copilot.
Yeah, so inside the IDE commercially, again, that one is baked into Copilot either for individuals or Copilot for Business so that you can go and get those automatic insights there. And we've baked in quite a few security mitigations there where we actually do suggestion rejections. So if you ask for a code that will make a SQL query, by default, it will actually reject things that are obvious SQL injection attacks or other sort of like OWASP top 10 issues. Okay. Those are baked into that inner loop for Copilot.
For Copilot. Are there any behavioral additions to Copilot when you license Advanced Security?
So not at the moment. Those are separate capabilities. The Advanced Security stuff around auto fixing, that's currently all definitively in the Advanced Security swim lane inside GitHub.com. But keep an eye out over the coming months and weeks. We are expecting to continue to innovate in this space and bring more AI capabilities into Advanced Security and more security capabilities into Copilot. Yeah. Next up.
Yeah. Good morning. Can you double click on license compliance? If I'm pulling in a third-party dependency and it violates my license policies, can I prevent it and get it into packages?
Yeah. So the way that we do that license compliance scenario, so there are two experiences that we sort of have baked into the product. One is that dependency review that we showed, where you can go and set up that GitHub action using a rule set, configure that with the set of either allowed licenses or the set of blocked licenses. And that will go and check at pull request time whether the dependencies that the developer has changed include blocked licenses. That is a separate issue, though, than your debt, right? You've got whatever you've got in your organization at the time you turn that on. We won't block on any of those. And so very specifically, we have another experience called Dependency Insights. It's github.com/dependency-insights. And that is something that will actually allow you to go and quickly filter down to see the licenses that you have, and you can go and drive a remediation program on that. All right, next up, yeah.
Yeah, we're both a GitHub as well as a Azure repos shop today. So looking at GHAS, we have GHAS deployed today. We're looking at GHAS till next. But on that security dashboard where you can see everything that's going on, can that roll in both of those sets of sources, repositories in that single dashboard view?
Yeah, great question, great question. So for folks that don't know, GitHub Advanced Security, sort of maybe at odds with the branding, but you can get GitHub Advanced Security on Azure DevOps if you have your source code stored there. And those are separate implementations. Currently, they don't talk. So the security overview that lives in github.com will only report on the state of things that exist in github.com. The experience that we have in Azure DevOps is only going to report on what's there. There is, however, and you can go up to floor 5 and go to the show floor, there's Microsoft Defender for Cloud, which we have as an option to go and do aggregation across multiple SCMs and multiple security tools. And so that's an opportunity if you want that security-focused lens of all of my vulnerabilities, regardless of where they live. You want to talk to the Defender for Cloud folks because they're interested in aggregating that all together for you. Yeah. All right, any other questions here in the room? Okay, well, thank you all so much for joining us early in the morning. Please power through the rest of Build today, and thank you so much. Have a good day.